It's a pleasure to be here with you. It's so exciting. So we're going to talk about modern Python through FastAPI and friends. First, a little bit about me. I'm Sebastia Ramirez. You can find me on the web, GitHub, LinkedIn, and Twitter. I'm currently in Berlin, Germany, so it's actually the midnight for me. And I create FastAPI and Typer, which are these open source tools. And I'm currently a software engineer at Foretold, which is a company in San Francisco using deep learning to solve and to improve the customer experience and customer service. And they are currently hiring, and the team is super cool. So if that's interesting for you, go check them out. Part of my job with them involves a lot of open source too, so I will get the chance to work a lot more on these tools, and I'm working for them 3 days a week, so I will be able to, on the other 2 days, work with other companies as an external consultant or just do more open source. I am Sebastián Ramírez, and I am from Colombia, so I have to say, ¿qué hubo, parceros? Qué chimba estar aquí con ustedes. Esto es muy bacano, estoy muy contento. And for those who didn't get that, sorry, that was in Paisa, which is a sort of Spanish. And the idea was to do this talk in Spanish, but as there are so many people from all around the world, we're going to do it in English, but with Colombian accent. So we're going to talk about modern Python, and by modern I mean all the currently supported versions, so 3.6 and above. And we're going to talk about a bunch of things. We're going to talk a little bit about f-strings, a lot about type annotations, a bit about async and await, a bit about performance and the community. And we're going to do this through FastAPI and a bunch of friends, Pydantic, HTTPX, Starlet, Ubicorn, Ubiloop, and Typer, and a bunch of friends, Rich, Click. And we're going to see all these features from modern Python through FastAPI and friends. Now, why FastAPI and what did they bring me here? FastAPI is a high performance and easy to learn web Python framework that is very fast to code, so it's very quick to write code in FastAPI, and it's ready for production. It currently has 32 something thousand GitHub stars. It's been growing about 1,000 per month, so a bunch of people have been liking it, which is great. Currently used by Microsoft, Uber, Netflix, and a bunch of other companies. And the performance is in the top rank for Python. So you get like pretty decent performance in like on the same ballpark of code written in Node.js or in Golang. Currently, FastAPI, as per the last official Python developer survey, is the third most used Python framework, right after Flask and Django. So that's super cool. And now we're going to start talking about, so, well, FastAPI is the thing that probably is more known that I built. And we're going to see a bunch of ideas and things that we can use in modern Python through FastAPI and friends. We're going to start talking about just pure modern Python, and we're going to start with a little bit about f-strings. So let's see some code. Let's say we have this data structure here. And this is just a bunch of recipes. We have a crunchy frog that has some ingredients, and we have an albatross that has some ingredients, and we have a default price of 1. And now we have here a function that will give us some information about some specific recipe. So this function getRecipe takes a name and takes a quantity, and the quantity has a default value of 1. And what we are doing is just we are extracting one recipe by the name, and then we are returning some information here in a dictionary about that specific recipe. So part of the information is this message here. And in this message, what we want to say is that, hey, this is the recipe for this specific, the name of the recipe. And in here, we actually want to put the name of the recipe. So we can use these curly braces and put this name here. And then we can use dot format. And then we pass the keyword argument name. So this name refers to this one here. And then we say, what is the value of this? This is going to be this value of this variable that is also called name. And this one refers to this one here. So this is the way that we are putting this name inside of this string. And as you see, we are repeating this name in 3 places. So with f-strings, well, first we can call that, and if we call this with the crunchy frog, then we get information for the crunchy frog. And if we pass a quantity, then we get like the extra information for the quantity. It's all fine. But then we can improve this code a little bit. So we have here this code repeating the name here, here, and here. And now we can just, instead of that, put this extra F at the beginning. And now this name will be taken from whatever variables are available at this point. So this name will come directly from here. So we save those a bunch of characters, but more importantly, we save those the repetition and the duplication of information, of code that can be cumbersome to handle and to keep in sync. And the rest is just the same. We are just returning what are the ingredients, and then we're saying that the total is just the default price multiplied by the quantity. So that's all fine. And if we try to execute it, it all works correctly as we were expecting. So perfect. Nice. That's all we had for f strings, but it's good to have them and good to know them if you are not using them already. Now let's jump to type annotations, and we are going to spend some time here talking a bit about type annotations or type hints. So let's see an example. We have the same code, we have the same function, but now let's say that we don't want to say return the data, just saying like, hey, this is crunchy-frog. We want to make it look like if it was normal text. So we want to, if we have a recipe that has one of these dashes, one of these little lines, we want to replace it with just a space. And we want to make the first character to be a capital letter, and also the first one of the other word be a capital letter. So we want this to be in title case. How do we do that? We are taking the name here from the parameters in the function, and let's ask the editor for autocompletion. So we say, hey, name dot, what was the name of the method to convert this, to extract and convert this line to something else? We trigger autocompletion, and the editor says, I have no idea what this name is, because you just declared it here as name in the function, so I cannot help you with that. And then like we are on our own trying to remember what are the names of all the possible methods that we can use in a string. But now, if we change this declaration here in the function, we instead of saying just name, we say, hey, this name is a string. Now, suddenly, we can go to the code, and because we say, hey, this is a string, now the editor knows that this variable inside of the code is a string. And if we trigger completion, the editor is going to be able to tell us what are the available methods. So we can see, it's replace. That's the thing that I was looking for. But even more, the editor knows that the result of replace, so if this thing was a string and we call replace, the result of this is also a string. So we don't have to declare it again somewhere, the editor already knows, and the editor can give us autocompletion for that as well. So we can call dot replace and then continue going dot title. This is the thing that we want. And now we have the final code, and the editor is helping us a lot with this autocompletion stuff. And that's because we are using these type annotations. And now, if we execute it, you can see that now it converted the line to a space, and we have the capital, each word starts with a capital. So nice, that's what we wanted. Now let's say that we want to do another refactor. By default, we're having a quantity of 1, but let's say that not necessarily everyone wants to get one of these plates. Maybe someone wants to have only the recipe and they don't want to be charged or something like that. So we can, instead of having the quantity equals 1, we can say, hey, I want this quantity to be just none. And yeah, cool, that sounds like a simple refactor. But now, if we execute this code, we get an error. And then we have to check, okay, what is this error? On line 32, we are calling get recipe. Okay, and what is the problem here? Is that on line 23, we have this thing here that is the total is the default price multiplied by quantity. And what about that? What's the problem with there? So there's an unsupported operand type for this symbol that is multiplying something. We are multiplying an integer with a non-type. Oh, so we are multiplying, this is an integer and this is a none. And this is the error. Finally, we got there. We had to run the code to get that error and to discover a bug in our code. But now, if we declare a type annotation for this quantity and we say, hey, this quantity will be an integer, or by default is none. Now the editor knows what are the expected types of this variable, and the editor can help us detect these bugs much faster. Instead of having to wait to run all the code to see where it explodes, we can see in the editor right away that there's a problem here. If we go and check it, we can see that it tells us exactly the same thing. we cannot multiply an integer with none. So the editor is giving us a lot of help just by doing this type annotations. Now let's fix that. Instead of returning directly a dictionary that is trying to multiply an integer with none, we are going to create the dictionary first, and then we are going to check. If quantity is not none, that will mean that quantity is actually an integer. Now we want to multiply quantity by the default price, and we just set it, and we just return the result. So yeah, that is what we are doing. Nice. But now, if you see, we still have a little error here. So what is this error? It's actually that the editor is trying to be smart and trying to figure out what is the type of this variable here, of this result. So in this result, we are creating this dictionary, and the editor is saying like, okay, I don't know what do you expect in this dictionary, but from what I can see in the stuff that you have given me, I can see that this should be a dictionary that has as keys strings, and the values are strings or lists of strings. And now at this point, you are putting a key, which is a string, and the value is an integer. But this is different than the stuff that I had inferred that you were giving me. So in this case, the editor is actually trying to be too smart, and we wanted to not try to guess so much of what are the things that we want to give it. So we can fix it very easily by telling it, hey, don't try to guess, this is a dictionary of what to what is the key and what is the value. Just I just want you to think that this is a dictionary of anything. So we can just declare the variable here and say, hey, this is a dictionary, and now suddenly we don't have this red line because now the editor will know this is a dictionary of whatever. Great. And as you can see, the editor knows that because we are declaring this quantity is an integer, by default is none. The editor knows that it's an integer, or it could be none. It could be any of those two. But if we check in this section in the code, we are inside of an if statement that is checking if quantity is not none. So quantity can only be an integer or none. And if quantity is not none, it means that quantity has to be an integer. And inside of this block, the editor knows that because quantity is not none, it has to be an integer. So the editor knows that inside of here, this quantity is an integer. So it knows, it's smart enough to know when these things change inside of the code so that it can help us properly do the things that we want. Now we can actually be more rigorous and be more strict and be more explicit about things, and we can say, hey, this quantity, well, is not just an integer that by default is none, because none is actually not a valid integer. So I want to say this quantity is an optional integer. Optional just means that it could also be none. And to do that, we import from typing. This is part of the standard Python library, and this has a bunch of things to add these type annotations. So from typing, we import optional, and we say, hey, this quantity will be an optional integer. And that's the way, like the most formal and structured way to declare that this quantity will be an integer or none. And that way the editor can help us a bunch with all these particular caveats. Now, these type annotations are actually built by people. There's people behind all these features and people behind all these things. The type annotations started as a project by this guy, Tosalo, that I'm probably pronouncing incorrectly. That was part of MyPy, and then that was integrated into Python itself. And also this guy, Ivan Dekivsky, that I'm also probably pronouncing incorrectly, and Michael J. Sullivan. All these guys have helped a lot to MyPy and to these type annotations themselves. And as you can see, they are just like guys. They are just some people trying to help others and improving the tools for everyone. Now let's actually see how can we use these type annotations even further. And here's where FastAPI enters. So we can use the same data that we have. This is the same data. This is the same function that we had before. And now we import from FastAPI, we import the class FastAPI, and we create an object app, which will be a FastAPI instance. And now we use the decorator app, and we say this is a GET request. So it will be an HTTP GET. And the path is /recipes, and this is a path parameter name. So as you can see, we're using the same syntax that we used for the F strings, so that it should be fairly familiar. But in this case, we don't put the F here, because if we put the F, it will mean that there should be a variable name outside here in some place. So we just don't put the F, but we use the same syntax internally to make it easy to remember. And now what FastAPI is going to do is that whenever someone sends an HTTP request to this path, for example, to recipes/crunchyfrog, which is this crunchyfrog here, FastAPI will extract the crunchyfrog from this path parameter and will put it in this name here. And then the quantity, because the quantity is not part of this path, the quantity will be a query parameter. So FastAPI will extract the default place to get this information from. And of course, because we are using the same type annotations, we get autocompletion everywhere in our code because everything is based on type annotations. And we also get the same type errors, type checks, because we are using type annotations. So we get all the features from standard Python, the features from type annotations. And on top, we get an API with FastAPI. Now, that code that I showed you is a complete API application. And if we run that with the server, if we go to /docs, we don't have to do anything else for this to happen. We get an automatic user interface for exploring the API that is generated automatically. So we can see that we have a get HTTP request that goes to /recipes, and then we have the name path parameter. And we can see here that the name is required. And this is a string that is in the path. And we also have the quantity, which is an integer, because we declared that it should be an integer, that is a query parameter. But it has a default value, so it is not required. And if we execute a request in this interactive user interface that we can explore in the web browser, the application is actually going to run and give us the result back. So this is not something that is saved somewhere. This is the result from the server live, and we get the response here. We have the recipe for the crunchyfrog, blah, blah, blah. Now, let's actually pass something to this quantity. So this quantity, if we pass the text 9, the editor, the same, not the editor, this is like the interactive user interface for the API, will actually tell us, hey, this is not a valid integer. This is expecting an integer. You should pass an integer here. So the same interactive user interface will prevent us from passing incorrect data. But of course, we can cheat and just pass it in the command line or from some code and send, hey, I want the query parameter quantity to be equal to the string 9, and just forcefully send it. As you can see, this is the URL where we are serving our application in this example. We go to /recipes/crunchyfrog. This is the name parameter, the path parameter that we were talking about, and the query parameter is this thing after the question mark. And we are saying, hey, quantity, I want it to be 9. FastAPI will check that this value is not a valid integer and will validate the data and will give us an error automatically that looks like this. And if we show it in pretty format, it will look like this. We can see clearly that the error in the request, the validation error, is in the query parameters, specifically in the parameter quantity, and the specific error is that the value is not a valid integer. So FastAPI is not only validating the data for us, it's also telling us exactly where are the errors. So this saves us a lot of work in our code so that the clients and the users and even us, when we are interacting with the API, can know exactly where are the problems. And FastAPI is also not only doing data validation, it's also doing data conversion. And the data conversion is like this. This is a valid URL that we are using. If we send a quantity of 2, this is how this will be sent. But if you notice, this is a URL, and a URL is naturally just a huge string. This is all a string, but FastAPI will say, hey, these 2, well, it comes as a string because it's in the URL, but this is can be converted to a valid integer. So FastAPI will go ahead and convert this to the valid integer. So in our code, we will not get a string with the number 2 inside. We will get a valid, an actual integer with the number 2. And you can see that, in fact, we are getting a number because the response is using the number as we were expecting it. FastAPI is based on standards like OpenAPI, which uses JSON schema, another standard, which is integrated. OpenAPI is also integrated with OAuth 2, which is this standard for doing authentication and authorization. And because FastAPI is based on these standards, we get all this extra interoperability like the automatic API docs. These automatic API docs are provided by this tool called Swagger UI. And we get that interoperability for free. And because it's based on standard type annotations, we also get we get like the default features of type annotations like autocompletion and type checks. But we also get automatic data conversion and automatic data validation, and of course automatic data documentation, because this is generated live automatically from the changes in our API. Now let's actually change a little bit. That's a bit for FastAPI with type annotations. Now let's see what else can we do with type annotations. Here's another library, Typer. We are going to do more or less the same thing, but now we're going to build a command line interface application. So something that we can run from the terminal or from the console. So we import Typer, we create a Typer app. This is pretty similar to building a FastAPI app, and we now say, hey, this is going to be a command. So we call app.command, and then we want to print it because we don't have a way to return a response to the user. So we are just going to print this in the terminal. And now if we try to run it, let's say we call Python main.py, then we can see that we are omitting the name argument. So now Typer is converting that parameter annotation with type annotations to a command line argument here. And we can see that it's doing the same data validation and all the stuff. And if we pass an actual name here, then we're going to get the result that we were expecting. So now we built a command line interface application with the same type annotations using Typer. And of course, we can we can use the quantity parameter here, and Typer converts that quantity because it had a default value. It converts it to one of these command line options. So we can call it with dash quantity and pass the value there. And then this quantity is used here in the result. And again, if we pass an invalid value, then Typer is going to do some data validation, and it's going to give us the specific errors telling us like, hey, this is invalid data. With Typer, we get shell or tab completion in all the terminals, in Bash, C shell, PowerShell, Fish, even PowerShell in Windows. I think there are not many, if at all, libraries for building command line interface applications that support PowerShell. And if this tab completions works like this, if we type, for example, Typer, blah blah blah. Okay, for this tab completion to work, we have to build an actual application and a package that can be installed in the system. So in this case, this package is called Typer. In this example, we could call it my super awesome package, and then we will run it like that. But the way it works is that we type the first part of whatever we're trying to get, we hit tab, and then it will autocomplete the rest of the valid options that we have. So we can call --q, and it will autocomplete quantity. So if we build an application, a command line interface application with Typer, our users will get shell or tab completion by default for free, sort of in their own terminals. Now let's actually combine this with more tools. Here's the friends that we can use with Typer. So we're going to use Typer and Rich. So Typer is great for building command line interface applications, but Rich is awesome for showing information and printing information, displaying information in the terminal. So we import from Rich, we import a table, and we import this console thing. Then we create this object console. I'm not going to show you like all the details, but in general, we can use these tools and combine them together very well. Here we are creating a table that has some title, and for each one of the ingredients, we are adding each ingredient to the table. And then we are printing that table, and then we are printing what is the total here. And now, if we call that from the command line, we get a very nice table that is printed by Rich. So Typer with Rich works great. Typer and friends have a bunch of people behind. So Typer is actually built on top of Click. Click is the tool that runs everything underneath. Click is the thing that does the data validation, for example, and that generates all the commands. Typer adds all this stuff to use these type annotations, so that it's very easy to build applications with it. But Click is what powers everything underneath. And Rich was created by this guy, Will McGuigan. So there's again, like just a bunch of people trying to help us behind the scenes. Now let's see a little bit more about these type annotations with FastAPI, and in this case we're going to use Pydantic. So FastAPI is built on top of Pydantic and another tool that we're going to see in a bit. And Pydantic is the thing that does all the data validation, data conversion, data documentation, all those things are done by Pydantic underneath. So now we are going to declare a different application. We are going to receive food items. So we create the FastAPI app. We say that now this is a post request, but now we are going to use with Pydantic. We are going to, from Pydantic, we import a base model, and now we're going to create a class food that inherits from this base model. And this food is going to have a name, and this name is going to be a string. So you can see that this is the same type annotation. So this is the same standard way of annotating this variable name in Python. And we're saying this name is a string, and the ingredients is a list of strings. And these ingredients by default is just an empty list. So with this class, we are declaring what is the shape of something that we want. And now here, again, in the same way that we were doing before, we are saying, hey, this food will be of type food. This is the standard way, again, in Python to say that this variable or this parameter or this argument, however you want to call it, food, will be an instance of this class food. This is how we declare it. And now we can use this food here inside our application, and FastAPI will take care of providing us an actual instance of this food. So we won't receive a dictionary or something like that. We will receive an actual instance of what we declared. So we can use it as we can get, for example, the attributes of this instance. We can get the food.name, or we can get each one of the ingredients from food.ingredients. And if we go to the documentation, again, to the same automatically generated documentation, we can see that now we have here the post request that we just created that goes to /food, and we have FastAPI is extracting that information that we declared with Pydantic and is generating the automatic example data of what we want to take. So this name will be a string and the ingredients will be a list. Or in JSON terms, it's a JSON array. And if we send some data, we can interact with this API live from this web user interface. We can send a name, the name will be albatross, and the ingredients is just albatross because this is just a big bird. And we just execute this, and then we get the response as we were expecting it from the FastAPI application. But now what happens if we send invalid data? So in this case, the name is a string, this is valid, and the ingredients, the albatross, that's valid because this is a string inside of the list that we declared. But now we have this extra thing here. This is, in Python, it will be a dictionary. In JSON, this will be a JSON object that has this additional stuff here. This is not a string, and we declared that we wanted a string only. If we send that, FastAPI will validate the data using the Pydantic model and will give us an error back right away, telling us exactly where the problem is. So we know that it's in the body, inside of the body is in the ingredients, and inside of the ingredients, the item with index 1, which will mean the second item because the first one is the index 0. And it's telling us that a string type was expected and we didn't send the string. So it's detecting the error, validating the data and sending us the exact error back. Now, let's say that we actually don't want to take a single orders. We want to take several orders. We want to take we don't want to take a single food item. We want to take several. Again, we just use the standard Python type annotations. The way that we declared this here with these ingredients is that these ingredients were a list of string, and this list we took it from typing here. So again, this is the standard library for doing type annotations stuff. We import the list and we declare, hey, these ingredients will be a list of strings. The same way here, we can say orders now is going to be a list of food instances. Again, this is the standard way in Python to declare that the argument orders will be a list of instances of the class food. And FastAPI will make sure that this is what we receive here. So by the point that our code executes here, we are already certain that we are receiving what we declare. We don't have to validate the data in here to make sure that we have the shape and the types that we declare, because FastAPI will make sure that we already got that. If we didn't send the correct data, then FastAPI will show an error right away. And now, because this orders is going to be an actual list of food items, we can iterate for each one of the food items inside of these orders. And because this is all based on the same standard Python type annotations, the editor can still give us autocompletion everywhere. So if you see, we are iterating for each food in orders. And then for each one of these food items, we are iterating for each ingredient inside of the ingredients of each food. And the editor, we are in a double nested for loop. And the editor knows that each one of these ingredients is a string, and is being able to give us auto-completion of the methods for a specific string. Because, again, we are just using standard Python annotations for standard Python type annotations for everything. And of course, we can also get automatic type checks and detect a lot of errors with this. Again, inside of a double nested for loop, the editor knows that ingredient is a string and we cannot sum a string with an integer, so we get the appropriate error. Now, there's also a bunch of people behind FastAPI. FastAPI is built on top of Pydantic, as I was telling you, and also built on top of Starlet. Pydantic is the thing that does all the data validation, data documentation, data serialization, and Starlet is the component that does all the web stuff. It's like FastAPI is actually Starlet on steroids, let's say, sort of. So Starlet is a toolkit for building a toolkit or a microframework for building web applications in Python. So, as you can see, this is also just normal people that are building these things. And for example, Tom Christie is the same creator of Django REST framework and the same creator of a bunch of other tools that we're going to see next. David Montaghi is, he just deserves a mention here because he's been a contributor to Pydantic and FastAPI and has helped with a bunch of things, especially 1 year ago or so. So, again, this is just like a bunch of people behind the scenes working for all the community to have all these features that we can take advantage of. Now let's actually change a little bit and let's talk about modern Python with async and await. What is all this stuff about concurrency and async and await, and what is it that we can get from that? Let's start with the basic problem. So code written in Python is super fast, and I'm probably the first person to tell you that Python is fast. But Python is super fast when you compare it to the network. So if you are building an operating system, you will probably use another language. But if you are doing web API, if you are doing machine learning, if you are doing data processing, the automation, a bunch of other things, Python is perfectly capable of giving you great results and help you be super productive. And it's super fast compared to the network. But then what is the problem with this? Is that the network is slow. So how could we solve this so that we can get like better performance from Python? So here's the first idea. Let's actually have, well, we will have a cloud server in Python, but let's have a bunch of clients, not only one client, let's have multiple clients communicating with the same Python web server. And that sounds great. And it's like, yeah, awesome, great idea. That should solve all the problem. But then in the traditional frameworks or in the traditional way of writing code with Python, this will actually not look like this. This will actually look like one of these lines waiting to pay at the cashier, and they are just waiting, like this guy is trying to get a wine bottle and still has to wait for the other one that wants to buy a bunch of toilet paper to be able to get that wine bottle. And just has to wait a long time until he finally gets to the cashier. And what can he do while he waits? Just standing there because someone could get in line, so he just has to put all the attention in standing there in line. This is more or less what it will actually be like. If we check it, it will be like we are serving each client one at a time, more or less. This is of course a simplification, but it will be more or less something like this. So Python in the backend will be fast compared to the network, but then we are waiting to serve each client at a time, and the network is super slow, and we're waiting for one client. After this one is finished, then we take care of the next, and then we take care of the next, and then we take care of the next. So this is not efficient. Then here's the idea. If we could have a waiter that actually goes to each one of the clients, instead of being like a cashier where people are just waiting in line to go and pay, we could have a waiter that goes table to table and asks for each one of the clients what they want. And if they are still checking the menu, then this waiter can go to the next client and check what they want. And then this waiter will go to the kitchen and tell them, hey, I need you to prepare all this stuff. And while the kitchen is preparing, this waiter will go and check more and more the tables. So it will look more like this. This is all our server in the cloud. And your application will be here. Your application will be the kitchen. It will be running on CPU, using all the CPU, using all the computing power to cook recipes, or whatever it is that it is doing. And then, as part of Python itself, these keywords, async and await, and these capabilities will be the equivalent of having a waiter, and it will be inside of Python itself. And what this waiter will do is that it will go to the first client, and it will say, hey, what do you want? Are you still checking the menu? Okay, then the next client. Instead of waiting for the first client to check the menu, order, eat, and pay, we can just check this one. This client still doesn't know. Let's check the next one. Does this client know? Yes, this client wants a bandeja paisa. So cool. Let's take that order and send it to the kitchen. Hey, I need you to prepare a bandeja paisa. The kitchen starts working, and it's like working full time on preparing that. And then the waiter can go to the next one and say, hey, do you know what you want? And this one is my sister, and she will take a very long time to decide what she wants. So the waiter can go to the next one. Hey, do you know what you want? No, still looking at the menu. Okay, let's check. Does the kitchen have anything to send? No. Okay, let's check back to this one. We don't have anything to do here because this client is waiting for the bandeja paisa. Let's check the next one. Do you know what you want? And I don't remember which one was my sister, but yeah, anyway, let's say that this one already knows. This one wants an ajiaco. So the waiter takes the ajiaco order, sends this to the kitchen, then continues with each one by one. At some point, the kitchen will say, hey, here's the ajiaco. So the waiter will then take this ajiaco and send it to the client, and then the waiter will keep checking each one by each one and taking each one of the orders and sending to each one of the clients. This way, we are serving thousands of clients from a single kitchen using this waiter in the middle. This is concurrency. So concurrency is being able to handle all these clients during the same period of time. It doesn't necessarily mean that we are serving each one of them exactly at the same time. It doesn't necessarily mean that the kitchen is preparing the bandeja paisa and the ajiaco at the same time, but the kitchen is never waiting to prepare something. The kitchen is being able to run at full speed, preparing a bunch of different things, and we are being able to serve a lot of clients, because the key thing here is that there's a lot of waiting for someone, waiting for the network, waiting for the client to decide, waiting for the stuff to be ready. There's a lot of waiting. So if we take advantage of that waiting, we can serve a lot of clients. In web requests, this waiting is just network. But that's the idea. That's what we get. Now, how does this look like in actual code? It's super simple. We have seen with FastAPI, we were using normal def functions, regular def functions. Now, instead of using our regular def function, we can use async here. And by using async here, now we can use inside of this function, now we can use things like this, await. And this await is what tells the sort of waiter, hey, this is a point where this could take a while, and you should go and take a look at anything else that might need your attention. And for this, we are using HTTPX, which is an awesome library for interacting with the web. This is it has the same API as requests, if you have seen that, but like it has superpowers, and it's compatible with async and await. So this is just how it looks like. For us to be able to use async and to be able to use await, the library like HTTPX or FastAPI has to be compatible with async and await. If it is not compatible, then We could do stuff like having like the example of the waiter could be just like staring at the same client in the same table, even though the client say like, hey, give me some time, I will just check out the menu. If the library is not compatible, it will be equivalent to having the waiter just standing there looking at the table and just not doing much. But when the library is compatible, we can use this wait and this async stuff and get like all this extra concurrency. Now, with how does this look like if we interact with it? It will just look the same. The API will all work and will all look the same. We get the response will just look the same, and everything will just work. But with FastAPI and HTTPX, this async and await are actually optional. So you don't have to learn them. You don't have to use them. You can use just regular function definitions in most of the places and use the same simple code or even the same code that you already wrote with some other tools. And then for the cases that require that extra concurrency and that extra performance, you can use a tool that is compatible with async and await and optimize only that specific path. But for the rest, you can just use standard regular functions. Now, some people behind these async and await things. Again, Tom Christie, the creator of Starlet and the creator of HTTPX and a bunch of other tools. Florimon Maka is a co-maintainer of HTTPX and others, and has been helping a lot with several parts of the community. Andrew Goldwyn is the author of the ASCII specification. This started in Django. So you can see, again, it's just like the community combining ideas and trying to help each other and putting a lot of effort into trying to help each other. Now let's talk a little bit about the performance. So in FastAPI, we get performance on the ballpark of the best that we can get in Python. This is a comparison. The blue lines are Python, the green lines are Go. Go is a compiled language, so it should be much, much faster than anything in Python. Nevertheless, for these things, we can get on the ballpark of like even better than some of the frameworks written in Go. And we get on the ballpark of the best that we can get with Python. The exact numbers are not necessarily very definitive because, for example, Ubicorn is the server that runs FastAPI and Starlet and everything here. So Ubicorn should be here on the top. Ubicorn is not even a framework. So we get some random error here, but the important point is that you get on the ballpark of this. And we've been able to handle 15,000 requests per second, so that's quite nice. Now, why is this? Why does this have this nice performance? It's because it's built on very nice tools. FastAPI is built on top of Pydantic for all the data validation, serialization, documentation, and Pydantic is built on compiled with Cython, which is a sort of compiled version of Python using C extensions for Python. The thing is that this makes the end result is that Pydantic is super fast. And on the other side, FastAPI is built on top of Starlet, which is the web toolkit or micro framework, and Starlet is run using a server like Ubicorn. Starlet or FastAPI. You just run the FastAPI application using a server like Ubicorn, and Ubicorn, which is the thing that implements the ASCII specification that we just read. You don't need like all these details to be able to use these tools, but it's good to see like why is it that we get this extra performance and why does it work this well? It's because Ubicorn that implements the specification uses UVLoop, and UVLoop is a high performance async IO drop-in replacement. It can just be integrated directly. It doesn't have to monkey patch anything. It can just be like used directly and give you a lot of performance. And UVLoop has all this extra performance because it's built again with Cython, which is the same thing we use for Pydantic. So that's why we get all this additional performance. It's actually thanks to the building blocks underneath. Now, some of the people behind this: Tom Christie, again, the creator of Starlet and Ubicorn. Yuri Silvanov, the creator of UVLoop. He's also the responsible for us being able to have async and await as keywords in Python. So he's a core developer building a lot of stuff inside of Python itself. Stefan Bellner, maintainer of Cython, I'm probably pronouncing it incorrectly. He's the maintainer of Cython, which is this thing that gives us all this extra performance. And you can see, like, it's just some guy. It's just one guy doing a bunch of things, like Tom Christie, doing a lot of things for a lot of us to benefit from. And that's where I want to go to the community. This is all done by normal people like you and me, making a bunch of mistakes and trying to fix them later. And this is mostly doing during the free time of all these people. And this is just trying to help others in most of the cases. But this is just like normal people. Now, the good thing is that you can help too. And this is what I want to motivate you to. For example, with FastAPI, you could translate a page. Translating a page could help a lot the local communities, for example, the communities in Spanish, or you could review translations from others, so you could answer questions from others. But I think that translations are a great example because only a few people can do translations. This is not something that everyone can contribute. Only someone that speaks two languages, like English and Spanish, can help translate documentation and translate things to other languages. And this also helps a lot of the local communities. So this is a great example. You can translate documentation for FastAPI, also documentation for Python itself, or for many of the other frameworks and libraries that you are using. You can also help with bugs or features, and you can help with other projects, like with all these other projects that I have been showing you, or with the projects that you care about, the projects that you work with. I probably don't even know many of those, but you can help them. There's always ways to help, and that's what I want to motivate you to. Go and help the tools that are helping you and that are helping others. Like, it's actually very cool, and it's very, very easy. It just needs to get started, but like, you can help too. Thank you very much. That's what I have for you all. If you want to check more about FastAPI, this is the documentation, and again, you can find me on GitHub, LinkedIn, Twitter, and all that stuff.